Well, certainly we've seen that as bandwidth demand has been growing just from an internet access and a business services perspective, operators have been rushing to offer carrier Ethernet services which can be deployed at much lower cost, and they can provide a much more competitive service to the customer. The work that the MEF has been doing to increase the reliability and performance and scalability attributes of Ethernet now has specific application for mobile backhaul. About a year and a half ago, the MEF standardized MEF.m4v, which was the first mobile backhaul implementation agreement. That specifies a number of different inner workings with the legacy network, and it allows a smooth migration to the all-packet networks of the future that will be used to backhaul services that were running over LTE. The MEF stands poised at being the only solution with carrier Ethernet to offer cost-effective bandwidth that's so much needed for 4G wireless backhaul. Right. So in addition to the bandwidth requirements that next generation backhaul has, you still have the requirement to do accurate clock distribution and synchronization over the network. So by tightening down the service level agreement, so we have very low packet loss parameters, very low latency parameters, and almost no packet arrival deviation or jitter parameters, it makes it easy to extend and to distribute clock out so that you get remote synchronization with the same kind of accuracy that you would get from a TDA, SDH, or a GPS device that carrier Ethernet is essentially replacing. Oh, absolutely. And the test that we've done, the MEF-18 circuit emulation over Ethernet test, is a very rigorous test that can certify carrier Ethernet's ability to deliver as accurate clock as you can get with any other type of networking topology or technology. The synchronous Ethernet is sort of the future for Ethernet. It requires essentially a wholesale upgrade. It's a new PHY chip that would be required in all of the equipment end to end through the network. So it's clearly something that's on the horizon. Carrier Ethernet is really agnostic. It doesn't matter how you carry the clock over it. So you can use adaptive clock recovery or differential clock recovery, the 1588 standards that are already in widespread use today, and kind of prepare, start by delivering accurate clock and synchronization using those methods, and then you have a network that's built and is ready when synchronous Ethernet becomes a more viable alternative. Sure. Essentially what you would have is a kind of a sandwich where you have the carrier Ethernet on the edge of the network and the transport, whatever that is, Ethernet over IP/MPLS, Ethernet over SONET, Ethernet over WDM, as providing the long-haul transport between the access networks. So you've got Ethernet on either end of the network connecting to the base stations and to the radio controllers, and then you've got some other transport network. And again, the carrier Ethernet is agnostic and can work with any of those different transport medias depending on what the specific operator has in place. If you look at the MEF's mobile backhaul implementation agreement, it's very complementary to the work that was done by the Broadband Forum with regard to IP/MPLS and the transport for mobile backhaul. You know, it really surprised me how fast and how widely it's been deployed. A year and a half ago, when we first standardized MEF-22, I was kind of anticipating that there might be a slow take-up, but really the operators, especially because they found that the clocking and the synchronization works as reliable as with these other networks, they're now rushing to carrier Ethernet because they can deliver 10 times the bandwidth at about the same cost as they're used to paying for legacy circuits. So now that the reliability and the interoperability has been proven out by a number of deployments all over the world, I think you'll start to see that deployment accelerate even further. Well, certainly the emerging markets are more innovative and have been the first ones to come in, but now you're seeing Ethernet deployed by the tier 1 carriers in large markets like here in the United States. So yeah, I'm seeing kind of global takeoff. It is in pockets. I think Europe is behind the U.S. and Latin America a little bit, but in Asia, Latin America, and in the U.S., carrier Ethernet is where everybody's going for mobile backhaul requirements today and in the future. Oh, absolutely. I mean, the scope of the first implementation agreement, MEF-22, doesn't even talk to LTD. It's absolutely a technology. Carrier Ethernet is absolutely a technology that can be deployed for the 2.5, and 3G networks that are in in use today, as well as building an infrastructure that will support LTE in the future. Absolutely. So it'll make it that much easier. If you have an Ethernet and IP enabled base station and radio controller, you don't have to do as much inner working function. So today we're doing a circuit emulation and clock distribution and timing are a big part of the implementation agreement. That will become less of a hard requirement in the future as more of the mobile equipment just becomes Ethernet and IP enabled itself.